Welcome to Project Hack 14. This is Challenge 1, Dynamic Teaching Performance Analysis. In our team, it's myself, Ben, Tavis, Mohammed, Rakshith and Rohan, and we are voices of BMTRR. The challenge owner informed us that they are wanting to improve their teaching and presentation delivery by having an ultimate goal of presenting and being able to dynamically adapt to a learner's experience, potentially leading to a deeper insight of teaching and allowing tutors to know that they are doing their best. Our solution to this challenge was to have an application in which presenters could use either a live session or recorded session to give them detailed feedback on their recording or presentation. This enabling them to receive feedback, reduce the need for invigilators to observe, as well as having more data than just attendees giving feedback.
We wanted the application to have two simple features. The first feature would allow the user to upload a voice recording and analyze this on the app using visuals. Ideally, we would also like another feature that would allow for recording and voice analysis in real time. An example of the application concept would be similar to VoiceBase's app. The VoiceBase application uses several types of analytics such as speech, text, and tone of sentiment. All of this data is organized using some sort of visualizations, and as you can see on the slide, there's a lot of useful data and actionable insights.
Hello, I'm Rakshit. We have used the 5 important analyses in our project. The first one is intonation index. It determines the pitches of a frequency in our voice. For example, the word sorry in a lower pitch differs from the higher pitch. The second one is articulation. It determines the clarity of a pronunciation. If the speaker lacks pronunciation, it's very difficult to understand. And the third one is rate of speech. Um, with a combination of number of pauses, we can able to understand if the class is a boring or if it is an interesting one. And the final one is the prosody index. It records the stress and rhythm of our voice. Basically, English is a stressed language. It has a lot of rhythm. If the speaker speaks in a very angry tone or in a different mood, it clearly offsets the condition, so we can easily label the condition of the mood of the speaker.
Feedback is presented to the user using a Power BI dashboard. The user can select which recording they want to receive feedback on from a drop-down list. Feedback is given in the form of traffic light scores, based off ideal speech patterns. Note speech gave a high score, whereas no emotion received a low score. The better pronunciation, the higher the score, and a low rate of filler words gave a high score. Ideal words per minute was given to be between 140 and 160, and ideal pauses per minute between 18 and 22. An overall score is also given.
In terms of future development, we would like to delve into parameters which are conceptually possible and technically feasible to be analyzed. We will try to work upon the live recording part, which due to limited time and some technical issues, we were unable to do justice with. We will try to analyze more parameters in terms of vocal analysis, which have been already discussed in the previous slides. We will try to develop a user-friendly application as well, which can be web-based or it can be downloaded from Google Play Store and iOS. And finally, we'll also try to compare against the historical data so that the performance analysis can be done in a holistic manner, and some kind of prescriptive analysis can also be given so that a person who is presenting can improve upon his skills.
From the dashboards, this would give the presenter a high-level overview on the selected categories and what their presentation style has been like. With future development, this would hopefully involve further integrations. Additional performance metrics such as tone reasoning to identify whether or not someone is tired, energetic, or stressed, or other options could be implemented. Methods of improving pauses and fillers would be added as well to help improve someone's presentation skills, and audience interactivity to potentially analyze how often the audience members are interacting with questions or statements that the presenter is giving. From conducting some research into this, we have found that there is potential future development that can enable speech recognition elements into the software and application to allow certain individuals' voices, specifically the presenter's voice, to be focused on in terms of the statistics and exclude audience interactions.